Hey there everyone, welcome back to part 3 of this Blender Cookie tutorial on creating advanced shader groups in the Cycles render engine. In the last part, we left off after creating the refractive and glass materials for our shader. In that shader, we used a version of Beer's law to create a transmittance value for the material. Now, before I do anything else in this part, I want to go back and touch a little bit more on what Beer's law is and how it works. Now, Beer's law is an equation which is used to calculate the light fall-off for a given material as the light travels through its volume. Now, this is an equation which states that it's basically a logarithmic fall-off. Now, again, I'm not going to go way in depth on how this works because there's already a great full tutorial over on Blender Diploma, but for someone who might maybe wanted to know a little bit more about what's going on rather than me just throwing these nodes at them, I figured I would give a little bit more of an explanation. So the things we have in this group are, we have a ray length parameter. I'm going to collapse that down. Our ray length is used. Basically, this is a parameter which calculates the distance a light has traveled after its last bounce. In this equation, we have it being modified via a divide node by a user set depth, and this allows us to set the depth at which the transmittance occurs. Here we have an option to choose a transmittance color. In a perfect Beer's law equation, this is not something you can choose, obviously. This is determined by the base color, which is then modulated by Beer's law. This version that I have chosen to use gives a little bit more artistic control and allows you to get some effects that might be difficult without a spectral renderer. Now, Cycles is not a spectral renderer. Cycles relies on the RGB color scale. Where that differs from a spectral renderer is in a spectral renderer, light is calculated via wavelength rather than color, and the color is just kind of a side effect of the wavelength. This allows for more accurate materials, but that comes at the cost of render time, and as Cycles is meant to be an animation engine, it chose the fastest options. So to get around this a little bit, we use this separate Rgb node so that each color channel can be modulated a little bit differently. So what we're doing is, after this divide node where we're using the ray length, we're dividing red, green, and blue out into their constituent values and running them through these power nodes using the modulated ray length as their power. So basically we are modulating the red, green, and blue of the transmittance color by the ray length. After this is done, they are recombined in a combine Rgb node and used to drive the color of this second glass shader, or refractive shader if that's the version you choose to use. We have a second glass node or refractive node which has the base color, and we mix these via a mixed shader using the back-facing node as the factor. What the back-facing node does is it takes face normal into account when it is calculating bounces. So basically, for faces that are facing the camera, it is currently using the standard base shader, and for when a ray encounters a face that is facing away from the camera, it returns the other shader. So basically what this allows us to do is to get a nice fall off within our object between facing faces and the back of the object, and this is what we use to approximate the Beer's law transmittance in our shader. I know that was probably a little heavy-handed for some people who aren't interested in that, but for those who are interested, that is how this shader works. So with that out of the way, we can get in and continue adding to our shader here. So we're going to add a few more things in this part. We're going to add, well, first we will just start with a nice extra for our glass and refraction. If we take a look at our render, you can see that we have a glass material, but an opaque shadow. This is obviously not ideal because glass doesn't cast an opaque shadow. We have the option of turning off no caustics down here in our render, but as you can see, this is slow and grainy, and if we waited for this to truly clear up, we'd be in the thousands and thousands of samples. And when you're working with animation, especially, that isn't something you have the time to wait for. So what I've done is I've kind of created a shader that allows for an approximate fake shadow and fake caustic effect at essentially no extra render time. It's basically a free effect and something that most people don't know exactly what it's supposed to be like, so you can really get away with it, especially for animations. So this is very simple to do. What we're going to do is we're going to add another mix shader down here at the end. The only other thing we need over here, actually it's going to be closer to the middle for organization, we need a transparent shader. If I go ahead and add this into the mix node, you can see that's not what we want. It really, adds transparency to our whole shader. So what we are going to do is add an input light path, and we only want it to affect the shadow. So we grab the is shadow ray. Now the way the is shadow ray works is in a path tracer, shadows are not cast onto other objects. They're calculated by light that is blocked from a light source, because light paths shoot from the camera rather than from a light in a path tracer. We can go ahead and collapse that down because we only need the is shadow ray. And as you can see now, it would appear that our shadow just disappeared, but that is because the color in the transparent shader is pure white. And basically what this is telling the shader to do is, hey, if you're calculating the shadows, use transparent. If you're calculating any other ray, use the result of all the shaders before this. So we're going to go into the transparent PSDF, and if we turn this down to a gray, you can kind of see what it's doing. It is giving us our shadow ray based on the transparent, or what this would be if it were a transparent material, which is okay for now. It gives kind of darker around the edges, lighter in the middle, but it's still not a very convincing effect. So what we're going to do to modulate this is we are going to use some vector math, some geometry math. Now again, this is a little beyond the scope of this, but I'll try to explain as best as I can what I am doing. We're going to grab a geometry node, and from this geometry node we are going to be using the normal and incoming values. The normal is obviously the face normal or vertex normal, whichever whatever is being calculated, and incoming is using the incoming camera rays, I believe. So we're going to grab this and we are going to go to converter, vector math. We're going to change this from add to a dot product. We're going to take the dot product of the normal and the incoming. And if I plug the value into the color here, you can see what we get. Now, dot product is vector math, or part of linear algebra. And it basically calculates the cosine of two vectors. So basically it is taking the normal vector and the incoming vector and finding their cosine value. Now, I know a lot of people probably haven't done that kind of math since high school or never did that kind of math, but it is very basic math. And you can see the result here. Basically what it's doing is, in these thicker areas, we're getting a darker color. In these lighter areas, we're getting kind of a focused effect. But it's still not great looking. This is basically just getting a very light fake caustic effect for us. So what we can do is modulate this by a color ramp to be able to choose what's going on here. So we can go to Converter, Color Ramp, stick it there in the middle, and we can use this ramp here to modify our product out of the dot product ramp. So I'm going to drag this down, and this is not an exact science what I'm doing right now. Basically, what you want to do here is whatever you think looks good as a caustic. The only standard thing you want to do is at the end, you probably want to raise this up just a little bit. I like to raise it to maybe 2, a little bit higher. And as you can see, that really gives the effect that light has been focused. We can add a couple more lines here, kind of tweak it a little bit. and really just work to get an effect that we think looks like a good caustic effect. You can use this to control the size of the caustic. Unfortunately, with this effect, light source is really independent of the result at the end. But it does allow a lot more artistic freedom simply by tweaking this color ramp node. So that's something I like for now. I think it looks all right. We're going to collapse that color ramp node. And the last step of this part is obviously, because of the color ramp, this would always just return a white caustic, which if we were to change, which looks okay right now, but if we were to change the color of this glass, the color of this caustic would not change along with it. So what we can do is get a color mix Rgb node, and we can multiply by whatever color we like. We can change this to red, get a red caustic, change it to green, get a green caustic, and just change this along with our glass color. So basically, this is completely set up the way we want it to right now. We just need to add controls. So the things we want to be able to control are the amount that we use the fake caustic. Sorry, let me zoom out a little bit more. The first thing we want to be able to control is the amount of the fake shadow. So we are just going to simply add a converter math node. This is going to be much like what we did with the Fresnel value for the reflective material. We're going to change this into a multiply, drag the second value out to our node group, and call that use fake shadow. By modulating that value, we will turn the fake shadow on or off. And this can be used other than, you don't have to just use this for the glass material. You could change the shadow of any object you want. Again, allowing for a lot more artistic freedom. Aside from that, we are also going to want to be able to choose the color of our fake shadow. So for that, we simply use the color of this modulated, this color multiply node here. Drag that over. Call that fake shadow color. And we'd like to be able to control how much of the fake caustic effect we get. So we can drag that down and call that use fake caustic. Oh, spelled that wrong, forgot a T. There we go. Now if we hop out, we can, I don't know, say we want a blue fake shadow. And we want to completely use fake shadow. I forgot to rename this last step at the bottom. Oh, this is going to be fake shadow color. Sorry, renamed the wrong thing. And this is going to be use fake caustics. So if we hop out, we can change use fake caustics to 0. And I may have switched those. There we go. We have use fake caustics at 0, so now it is just using the fake shadow. We can turn that to a brighter color if we like. There we go. We've got a green shadow coming out of our, or a green opaque shadow coming out of our clear glass. We can turn on use fake caustics, let's say 0.6, and we get a fake green caustics coming out of our clear glass to make this look a little more reasonable. There we go. And you can see we get basically a free caustic effect out of this shader. Very, very useful. So that is completely set up. We can move on to the next thing. The next thing that we're going to add, we can collapse these down to save some room for now. The next component that we will be adding is simple emission. This will allow us to, from within the same shader, turn this into a light source. And this is very simple to add. This is just a shader emission. mix node here at the end. And a mix between our results so far and emission. Drag the factor over. Oops. I'll get it one of these days. There we go. Drag the factor over. Create a new socket and call it use emission. Create parameters over here for the new sockets that we need. Emission color and emission strength. Give those names. And for right now, I'm going to turn off fake shadows, so put that to 0. And you can see there we basically just have a glass material that is emitting a little bit of light. You turn that to 1. Now it's only an emitter. Turn the emission strength up, and we have a Suzanne-shaped light. So we turn that back to 1, turn emission to 0, and we have just our glass. Next, we're going to add a little bit more of a utility shader. It's going to be a matte shader. Now, this will allow us to set a basically just a color that is only affected by the camera rays. It'll still, every other thing in the scene will still be affected by what we actually have created with the materials before this, but the camera will only see a flat color. And this is useful for things like compositing in a external program such as After Effects or Nuke or something like that. So Cycles doesn't have a set matte node, so you can't just set a flat color. You could use a holdout node, but that is limited to just being black. You could change that in the compositor if you wanted to, but this allows you to do it in the viewport. So we're going to add another emission node. We're going to set the strength to 1.5. This isn't going to be something the user can control. And we are going to add another mix node. So we're going to duplicate that one. And I know it's getting a little hard to see, so I'll explain what I'm doing as I do it now. We're going to take the emission, plug it into that new mix node. And rather than just mixing standard, as you can see, that's not exactly a great effect. We're going to add another light path. And we're going to use the is camera ray, and basically this will make it affect so that the second input to this mix shader will only will be used only for the rays that the camera sees directly, so only for the first hit of the rays that are shot. Plug it in, you can see it's a little more obvious what that does. Let's see, I can show this a little bit better. If I turn off refraction transparency, and I turn off the glossy weight, I turn the diffuse weight up, and let's set the diffuse color to something like red. It's hard to see because of the background image that we're using. But basically, it's only calculating the white for the first hit rays. These shadow rays are still calculated as if it hit a colored object and bounced onto the ground. And the reflections of anything that sees it will not be this white. They will be the standard material as well. Again, this is more of a utility. This is good for exporting to an external package. If you were to set this on its own layer, it would make it very easy to edit later. The other thing you might want to be able to do with this node is control the opacity of the matte. So basically all we're going to do for that is, much like we did with the glass, we're going to add a transparent shader. Grab that. We're going to add a mix node, but rather than put it at the end, we are going to put it before the shader we created up there. So we're going to be mixing the emission with the transparent. Again, we only want this to affect the camera, so we're going to add another light path node. Use the camera ray. And as you can see right now, it's kind of disappeared. So we need to set a parameter that allows us to control this factor. So the way to do that is we're going to create another socket here at the bottom. We'll just use the plus key, or the plus button rather. And we are going to rename this to mat alpha. And we are going to multiply, again, mat alpha using a math node. Multiply is camera ray by the mat alpha value, and use that as the input here. Now, as you can see right now, mat alpha is 0, but we can see it, and if we go to 1, it disappears. So obviously that is backwards. All we need to do for that is somewhere between the mat alpha and the multiply node, we can put in a color invert node. And that's it. It's good to go. Mat alpha 1, visible. Mat alpha 0, not visible. Mat alpha 0.2, sort of visible. There we go. So we can get that out of the way. The other things we need to be able to control are the mat color. So we can basically take the color from that emission node, call it mat color. We can put that above the mat alpha. And the other thing we want to be able to control is whether or not the mat is turned on. Right now it's only using the light path, so it's basically always on. And again, it's just a simple multiply node that will allow us to control the effect of that. So we're going to put the light path there. We are going to connect a node from the node group to the bottom socket of the multiply node. And we're going to call that use mat. Move that above the mat color node, or mat color parameter, and use that as the factor for the mix node. Alright, right now it's at 0.5. This should really only be on or off. So if we're not using the mat, we get our green. If we use the mat, we get our white, or we can change the color of that to whatever we like. Again, a very handy utility shader to have for someone who might work with compositors outside of Blender. All right. So the only other utility shader that we're going to add here is we're going to add the ability to control the overall opacity of our entire shader. This is, again, very easy to add. It's just a simple mix shader. We are going to add another transparent shader. We could technically use the same one, but I like to use separate ones just to keep it clear what everything is there for. So we're going to take that, plug that into the new mix node we just created. We're going to take the factor of that mix node we just created, plug it into our node input, and we are just going to call that overall opacity. And we are going to drag that all the way to the top of the stack. All right, if we go out, take a look at our stack as it is right now. We have overall opacity 0.5. We can set that to 1, and it makes it go away. So obviously these are switched. So we just need to switch the two inputs on that last mix shader. Opacity 1, it's on. Opacity 0, we have no object. That is the majority of our shader. You'll notice that one key thing that's still missing is subsurface scattering. Now, in the shader stack, we obviously want subsurface scattering to come before our glossy is added. So if you give me a second, I'm going to set the shader up in a way that's a little bit more clear to see. I'll be right back. Okay, basically all I did was turn off matte. You can see that we have our simple diffuse material here, and in the stack we are going to be adding subsurface scattering. As I said before, we want it to come before glossy is added. So we're going to grab everything below glossy. You can use B to box select, just like in the 3D viewport. We're going to move that down just a little bit. That should be good. And we are going to add our subsurface scattering shader. We need another mix node. We are going to mix with the holdout, as we did for these other basic shaders at the top. And aside from that, we just need one more add shader between diffuse and glossy, where we will add on the subsurface scattering. The only other thing we need to do is add in all of the variables. Subsurface scattering normal does not work right now, so there's no need to add that at the moment. In the future it might work, you can add that in, but right now it would just cause extra confusion and problems. So I'm going to pause, I'm going to rename this, I'm going to put them at the right place in the stack, and I'll be back in just a second. Okay, I've just renamed subsurface scattering color, subsurface scattering scale, and radius. The only other thing we need is a way to control the weight, and again, this is just going to be the factor between the subsurface and the holdout. Add that to the bottom, scroll down, call it SSS weight. I'm going to move that up so it's above the other subsurface scattering parameters, just holding with the convention. And that is all set. We hop out. We're not going to be able to see it because we are in GPU mode, and subsurface scattering does not currently work in the GPU. But if I turn it on, it's a little bit slow, but you can see we've got the lightning from the subsurface scattering there. It'd actually be easier to control subsurface scattering from the properties panel. And as with everything else, this entire shader is made to be used from the properties panel, which is a little bit easier for artists usually. So here we have our diffuse. We can turn our diffuse off and you can see just what the subsurface scattering looks like. Put the weight to 1, and let's play with the radii a little bit. Let's do 1, 0.5, and 0.25. And you can kind of get a feel for what the subsurface scattering is doing. It takes a little while to clear up, but as you can see, we're getting more red in these areas where the light is scattering a bit more. In the thinner areas, we're getting a nice waxy effect. On top of that, we could even add a little bit of glossy. 2.6. Again, it takes a little while to clear up, but it's a handy shader to have, definitely. So that is our subsurface scattering added to the stack, and in essence, our Ubershader is complete. In the next part, what we'll be doing is doing a little bit of cleanup here on the shader, because if we hop in right now, you can see that things like overall opacity, oh, that's not a good one. Let's take a look. We can find something that's not right. So, for instance, subsurface scattering scale, we have a minimum of 0, a maximum of 1 million. Probably more than we would ever need. For things such as our MAC alpha, we have negative infinity to positive infinity. Those are way more than we should be allowed to put in for those values. So basically what we're going to do in the next part is we're going to frame everything up. So we're going to be able to say these are the diffuse components, these are the subsurf components, these are glossy, etc., etc. And we're going to make sure that everything has a sane minimum and maximum value. Aside from that, we are going to be doing a quick time-lapse that shows how you can use just the single shader to quickly create materials for an entire scene. And that will be the conclusion of this tutorial series. So I hope this part was helpful for you. Again, in the next part, we will be doing a overall or an all-encompassing explanation of what everything does here. And again, if you are confused about what any of these parameters does, you can watch part 1 again, where I basically go over everything and how it works. So that's it for this part, and I will see you in part 4.